Okay, I'm going to show you what it looks like when we set up and do a melt. So here I am in the barn, and we're just going to start grabbing stuff, setting it up, and we'll get her going.
A chimney, and you can see that it is lined with ceramic wool and actually a coating of satinite on the lower part of it as well. If it didn't have the lining with the ceramic wool and satinite, that chimney would melt in a very short time. I use the chimney is because some of the neighbors are sensitive to noise, and using that chimney does reduce the amount of noise.
Loaded it up with the Crucible. You can come on in and take a look. I've got about 35 pounds or so of iron scraps in there. And now it's time to put the chimney on.
Those are actually not scraps of iron so much as they are returns from the commercial foundry and my foundry. The chimney itself attaches with a couple of 5/16 hex head bolts, keeps it from falling off.
The chimney is just a piece of galvanized ducting that's lined with ceramic wool, just like this stuff that's on top of the lid here, but it's lined in there with ceramic wool.
If it weren't lined with ceramic wool, that chimney would melt in short order. Makes it convenient to keep most of the gear that I need related to my furnace all in one spot and out of the way, and I can just roll it up into the area close to the furnace when it's time to get started.
This is part of the hoist mechanism. This is my burner tube with the atomizer inside, combustion air here, compressed air here, and fuel in.
Spoke there, unfortunately. The short tube is the compressed air and the long tube is the fuel in, and you can see the filter on it.
I have a filter on the air, the compressed air, so that it doesn't plug up the jets on the atomizer. Now we're hooked up to compressed air. Next thing is we need electricity for the fuel pump and for the combustion air blower. This is the power supply. This is a 12 volt DC power supply that will provide power for the fuel pump. I use a Holly fuel pump, just like you use in the car, to pressurize the fuel for the burner. That fuel pump is right in this box. You can see it says Holly on the end.
The box also contains an accurate fuel flow meter and a pressure gauge.
5-gallon jerry can that I welded a spigot onto. And here's the 12-volt power supply. We'll plug her in and you can hear the pump. If you come around this way, you can see the pressure gauge right here. We've got about 13 pounds of pressure right now. And I'm going to clear the display from the last burn and then get it on run. So we're ready to roll. Ready to run. This is the actual fuel supply, and it plugs into the burner with this little coupling. We'll fire that up in not very long. So, I feel like we're pretty close to ready to go here. Got to get some compressed air going. What's going on with that? That's weird. There we go. I put on just a little bit of air at this point. We'll get a lot more later, but that's how that's set. This is combustion air. What we have here is a vacuum cleaner motor enclosed in a case that's supposed to reduce the noise so that we don't bother the neighbors. Little 3D printed adapter there. Well, maybe we won't. I think we just tripped the circuit breaker.
The way for me to light my furnace has been by dropping a fuel-soaked rag burning into the furnace with the flame of the rag being right at the entry point of the burner tube. And I turn the combustion air on very low, just barely any combustion air at all, and the atomizing air is at about 5 pounds open.
Control the airflow from the blower here. That's wide open. Pretty closed down. We started with it pretty closed down. Otherwise, the furnace blows out. I think we're ready. Take a look in there real quick. I'm turning on the compressed atomizing air now. Hear the furnace changing.
Burns a lot different when it's just getting started and it's cold. Once it gets up to temperature, the fuel atomizes better and it just burns a whole lot more efficiently and gets white hot inside. You can see we're running about 0.18, 0.19 liters per minute. That's about the flow that works real nice for this furnace. Okay, now it's a matter of just me keeping the furnace tuned properly and preparing the molds, bring them out, get them set up, and so on. I'm going to go ahead and tune the flame on the furnace just a little bit so you can see what that's like. Right now it's running without much flame at all visible, but if I cut the air, the combustion air back, you'll see that a fairly luxuriant flame comes out of the chimney, and that means I don't have enough combustion air. If I put too much combustion air in, then the furnace is cold. So what I try to do, and what I've learned to do based on the amount of fuel flow that I have, is to adjust the air so that the visible flame just goes away, and that seems to give me an optimal burn time. So let's go ahead and let's cut back some combustion air. You can see what that looks like. That's way too rich. That's about right. Well, the melt is ongoing out there. And what needs to happen at some point is for me to get that mold and that mold out to the pouring area. So naturally, I've used the spreader bar and hoist to get this mold down there on the floor, and there's a little bar underneath it that has some cable on it that will hook up to my version of a straddle lift truck. We'll show you that in a minute. I thought I'd show you how we get those molds down onto the floor. Hoist is just on a garage door track up there. We'll let it down. It's a little bit out of order. It should have been before the prior segment, but I think you get the idea.
It gets down close there. I tend to pull it over a little bit. Makes it just a little easier to back the lift in. That'll work, just like so. And up it goes out of the way. So this is my impression of a straddle lift truck. It's a simple garden cart that has the legs extended a bit, you can see, and then has this bar added here that's lifted by the jack that used to be in my old Nissan truck. And in that fashion, I can straddle that mold, lift it up, and roll it out to the pouring area. And we'll demonstrate that here in just a moment. Now we're going to hook the mold up to the straddle cart. We just have a little, I think that's 1/4 inch by maybe 4-inch bar down there with a cable on it. It hooks onto that little nubbin right there, and then I'll crank her up. Ever so slowly, the jack is extending here. And in a moment, the flask will start to lift off the floor. I think it's going up now. When it comes up firmly under the truck, the resistance increases considerably. So I usually give it a little kick to make sure it's stable, and it is. And now we're going to just walk it on out to the pouring area. I think this mold weighs about 150 pounds. There's no way I can get that out of here without some sort of transport device. Then we'll just let her down. Now we're ready to go get the next one. The real advantage of that straddle truck is it allows me a nice controlled lift and a nice controlled setting it down. If I were to do that with, say, a hand truck, it'd be a lot harder to manipulate that mold gently. I think it's important to manipulate the mold gently so as to not cause sand inside to collapse unexpectedly. Time to get down to brass tacks here. I'm going to re-slag the Crucible, and then once that's done, we're going to add some parasilicon. So I just turned off the fuel.
About 55 pounds of iron in the Crucible, and that should allow for a little extra iron at the end. You sure don't want to run short of iron as you're pouring, so it's much better to allow a little extra.
All right, we've done a pretty good job of getting most of the flag out of here, and the ceramic filter will take care of whatever I missed.
There's about 55 pounds of iron in the Crucible, and I'm going to pour it as fast as I can into each mold because a rapid pour seems to result in better castings. So this first pour takes about 10 or 11 seconds. And I think a similar amount for the second one. I will have a little bit of iron left over, which is very, very desirable. You're sure to be short. And that extra iron I'll just pour off into the quote overflow end quote pot there so that it can be picked off and used later.
These are some of the flames from the venting gases from the epoxy resin that is burning off. Right now I don't see it around the edges of the flask, though I often see it there. That's pretty much all she wrote. Well, the party's over. It's time to finish picking up. I've got pretty much everything all picked up out here except for the flasks. I like to let them cool and take them in last. And looking at this pouring basin here, I can see just the faintest, perhaps, glow. It's got to use your imagination a little bit, but I can see that. And it's quite reduced light, as it is definitely dusk right now. But that would indicate to me that probably the temperature of that pouring basin's around 900, 950 or something like that. We'll check it when we go inside. But the point is that easily 40 minutes have passed since I made the pour, and that iron has cooled down very nicely, very gently, and that contributes to stress relief and nice soft iron. So let's go ahead and see if I can get on the hand truck here and roll it on inside. So in here, I have swept the floor to try to reduce the amount of pine needles and other debris that would otherwise get mixed with the sand when I shake these out of the mold tomorrow. I'm always curious to shake them out right now and see what I have, but I know that it's much better practice to just let them continue to cool down for at least 4 or 5 hours, and typically I let them go overnight. But everything went well on that pour. There's every reason to believe that things are okay, but there's no guarantee.